is 11.1a, which is all about space figures. Pretty much what that means is space figures are just three-dimensional figures. So they have length, width, and depth, right? Or height, width, and depth, however you want to think of that. So we're going to talk about what are called polyhedrons today, which is a big word. But really what it means is it's a 3D figure whose surfaces are polygons. Okay, so a polygon is like a quadrilateral, a pentagon, a hexagon, right? All those things. So this, for instance, would be a polyhedron because every face that you see is a polygon. You have parallelograms, you have triangles, that's a polyhedron. Okay? This is a polyhedron because all your faces are rectangles or squares. So polyhedron. This is not a polyhedron because it's a circle base, and a circle is not a polygon. This is a cylinder, yes. But this would be a polyhedron. This would be a polyhedron. Anything that its faces are polygons, okay? So what we're going to do with that is we're going to look at the faces, the edges, and the vertices of some different figures, and I'm going to give you a formula to go along with it. So this first one, okay, so let's say this is our figure. This is R, U, T, and S. We're going to talk about faces and edges. Actually, scratch that. We're going to do vertices next because then it'll be in the order that you're going to see them in. Bless you. Does that green show up okay for you, or do you want me to use a different color? I can do like purple or something. You need your glasses, girl. Can't see without glasses. Velma.
I can't see without my glasses. What does that say? Holy.
Faces, vertices, edges. Oh, polyhedron. Are you up there right now? You need to get in the game, girl. Okay, so first thing we're going to do is just identify what a face would be, okay? So in this figure, actually scratch that. I mean, don't scratch it, but we're going to go down here first. Draw a rectangular prism. Do you know how to draw a rectangular prism? Draw a rectangle in the front, like this, and then go diagonal back off of each corner. Put a dotted line right here, and then just connect them in the back, but dotted lines here. Okay, so faces, edges, and vertices. Your faces are the polygons. So, for instance, this rectangle here is a face. Okay, so your faces are all the polygons. So how many faces do you see in that rectangular prism? How many faces would that have? It has 6, right? It has the 4 rectangles around the edges and then the top and the bottom. Okay, so that's a face, and a face will always be a polygon. Okay. Vertices, do you know what vertices are? What's a vertex? Vertices are just the plural of a vertex. Points, right? This is a point where 3 or more lines meet. So your vertices are all here. How many vertices do you have? There are 8 of them. Okay, so the plural is vertices, but it is one vertex. And that's where 3 or more lines meet. So there's those 8. So a vertex is 3 or more lines meet. Okay, and then the last one is edges. And for edges, it's just where 2 faces meet up. So like this line here, that's an edge. So an edge is where 2 polygons meet. Well, let's say 2 faces. Okay, so how many edges would you see in this picture? So that's the purple. There's 4. And another 4. And another 4, right? So there would be 12 edges in that. We just stick that on my desk. Oh, yes. I will try to remember to do that as soon as I'm done with this. Okay. Thank you, Ashlyn. So faces, vertices, and edges. What'd you say?
I said I'm right.
Oh, thank you. I know, right? She wins the TA award. Yep, keeping me in check. So let's look at this example 1 that we drew up here. How many faces do you see there? So essentially that figure is this, right? The base is a triangle, and then it has the triangles all the way around. Okay, so how many faces are there? No. Has a triangle on bottom, and the triangles around the edges. 4, right? If it was a square face, then it would have 5, right? So it's always however many sides your base has plus 1. So this would have 4 faces. Okay. How many vertices does this one have? How many points where 3 or more lines meet in this picture? It has 4. You have 1 here, 1 here, 1 here, 1 there. Okay, so 4 vertices. And then how many edges?
50,000.
That's a lot. Let's count. 1, 2, 3, 4, 6, 5, 6. Okay, so 4 faces, 4 vertices, 6 edges. Okay, that leads us into a formula. It's called Euler's formula, but it looks like Euler's formula. But the guy's name is spelled like this. But it's Euler is how you say that. So this guy, Leonhard Euler, he was a Swiss mathematician. He came up with a formula that he named after himself, or someone named after him. And it just talks about the relationship between faces, vertices, and edges in a polyhedron. Okay, here's the formula. And this is for a 3-dimensional figure. So if you're dealing with a 3D figure, the formula says that you can take the number of faces plus the number of vertices, and it will equal the number of edges plus 2. So F plus V equals E plus 2 in a 3-dimensional figure, okay? Where F is faces, V is vertices, E is edges. So what you're going to do with this is you're going to use Euler's formula to just verify that the numbers you're finding are actually correct, or you'll use Euler's formula to find a missing number. So you'll just be plugging things in that situation. So let's do this one. And you can try to draw this as best you can, or you can just watch me for now, because this is not the easiest one ever to draw. Basically what you have is a square pyramid on top and a square pyramid on bottom. but give it your best shot. Or just watch mine. Okay, can you see it? So it's like this. Hello. It's like, you doing okay back there, Cameron? It's like this and this, right? This is on top and then this is on bottom. So if we are using Euler's formula, let's just walk through faces, vertices, and edges, and then we'll see if his formula works out with the numbers that we find, okay? So how many faces do you see? How many?
7.
It's not 7.
9.
I know why you said 9. You have to take one of them away. The one in the middle, right? This,
6.
the square in the middle, you're not going to include because it's inside the figure. So,
I was thinking that if they're both stacked on top of each other, I didn't count the 2 because it's 2 figures, so I counted it as 1.
right, yeah, we don't count it because it's like this, right? I mean, it's not because these are different figures. But say these were the same figure, your surface is just the outside of it. So you're not going to see this face, right, if they're put together.
So it's just 8.
So it's 8. Yeah, so you have, do you want me to shade the 8? Do you know, are you all seeing where the 8 are?
So just the outside.
Just the outside, yeah. Okay, so your faces is 8. Do you see it, Cameron?
Yeah, I thought it was another 3-sided triangle. That's why I said.
Oh, gotcha. Yes. Okay, so now vertices. How many vertices do you see?
16.
6. How are you getting 16?
All the little, one at the top. Yeah.
One at the bottom, and then just the 4 around the edges.
Oh wait, you don't have to multiply those. I was thinking that there was one for each triangle.
Oh, I see. You're using it for every individual triangle. Okay, that makes sense. I was like, where is 16 coming from? But yes, that would make sense then. Yeah, you just use the 1 point because it'll be on all 3 of them, but it's 1 or on all 4 that are coming together. Okay, so you have 6 vertices, and then how many edges?
13 or
12. So you have 1, 2, 3, 4, and then 1, 2, 3, 4. Bless you. And then 1, 2, 3, 4. Right? So there's 12 edges there. Okay, so now let's look at Euler's formula. If we plug into this, it's faces plus vertices should equal edges plus 2. Is that a true equation? Does 8 plus 6 equal 12 plus 2? Yes, it does. 14 equals 14. So that means Euler's formula checks out. It worked. We found the right number of faces, the right number of edges, the right number of vertices. Okay? Questions on that? Okay. He also has a 2-dimensional formula. This one we don't do as much with, but when it's a 2-dimensional figure, in other words, when it's a net, remember how we would lay a figure out, lay it flat? If it's a flat version of a 3-dimensional figure, then it's faces plus vertices equals edges plus 1 instead. So just don't get them confused. 2-dimensional is plus 1, 3-dimensional is plus 2. So it's like you're just taking 1 away each time, okay? So if this is our figure, what is this a net for? If I folded this up, what would it make? What? A rectangular prism, which if they're all squares, it would be a cube, right? Okay, so if it's faces plus vertices equals edges plus 1, how many faces do you see right now?
So 20.
6. Right? So there's 6 faces. How many vertices? 12. You have 1, 2, 3. Oh, I lied. It's not 12. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, 14. How many edges? Yeah, this one's hard to count. We'll just do it together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so now you check. The two-dimensional formula says faces plus vertices equals edges plus 1 instead of plus 2. And then add that together, 20 equals 20, so it does check out. Okay, so if it's a flat figure, you use this one, f plus v equals e plus 1. If it's a three-dimensional figure, f plus v equals e plus 2. Okay? Questions on that?